Hello everyone, welcome back to SCALER YouTube channel. Myself Vamsi. In this particular tutorial, we will be solving another most important dynamic programming interview question named edit distance. Okay, so the problem statement and the solution and all the optimized approach we will be discussing in the video. So I highly recommend you guys to watch this video till the end. Okay, so if you are visiting channel for the first time, please don't forget to subscribe. If you like the video, please hit that like button up, and please let us know in the comment section how did you feel about this particular video. So now let's discuss the problem statement. Okay, so the problem statement will go something like this. You will be given two strings. Okay, two strings. So let's say s1 and s2. Then you need to figure out. Okay, you need to figure out total number of operations. Total number of operations that you require to convert s1 to s2. Okay, so the operations that you can perform were insert, delete and replace. Okay, and each operation takes one, let's say cost of 1. Okay, cost of 1 each. So I hope you got the point. Okay, let me just try out few cases. Let's say I have given you a string, two strings, as s1 as Sunday and s2 as a Saturday. Okay, now you need to convert your Sunday to the Saturday. Okay, that operations that you can perform is either delete, insert, delete, replace. Okay, now let's say what is the one way that you can convert this Sunday to Saturday. So I will just insert all these things. Okay, like I will, instead of having S, A, then T, then U, then R, then A, then D, then Y. Yes, I can do this. Now tell me how many operations that I have made. So I have replaced U with the A with the U. Sorry, I have replaced U with the A, then T, then U. So at each time, so all these were replace operations, and these two were insert operations. So this is one possible. So here the total cost was 7. Yes, 7 operations. Now what is another possible that way I can do? So let's say here, instead of I decided to, okay, so here I have a day, right? Yeah, I will keep that day and I will change these things. Okay, I will delete these 2. Okay, or I will replace. Okay, let's say I have replaced this 2 with A, T. Now I will insert U, R. Now tell me in total how many operations that I have made. I made 4 operations, which is a way more less than the 7, right? Yeah, it is also valid. Yeah, and again, and what is the next thing that I can do? Let's say this is the best. Okay, so just check. Okay, what are all the possibilities that we have? So S matches. Okay, let me write this Saturday as well. Yes, this S and this S matches. This D, this D. Yeah, good. And I have U, and yeah, I have U. Now I will replace this N with R, or yeah, R. Now I am done with all these things. Now I have these two. I will insert them. Okay, yes, A, U, A, T, R. Now in total, how many operations that I have made? 3 operations. Can I say out of 3, 7, 4, like all the possibilities, 3 is the one which took minimum, right? So 3 is the minimum. So you should return 3. Got it? Got it. So yeah, I hope like it will give a good picture if you try out with other possible examples on your own. Okay, so now please pause the video for a while. Now think about the solution that you can come up with. Okay, so let's continue. So here I have taken jam and sm. Now I wanted to convert this jam to the sm. Okay, now let's say what is the one thing that I can do? Insert. So where I need to, so currently my indexes are here, means at 0 comma 0. Okay, so so whenever I made an insert, it will looks like something like this. Okay, s a m and s m. Okay, now I have this s and s first shown. So since I have inserted the same number, I'm pretty much sure that s will have, means this second s2, the index which I am currently. So now I just need to go the next character, right? So which is m. Yes, so now currently I am staying at 0 only yet. So this jam, so basically we are not inserting. Okay, we don't care about the values, we just care about the number. So we are not just inserting, but we are just for assumption I am writing s. Okay, so still we have made one operation, okay, plus 1, and we are still just checking whether this j will match with other characters, other set of characters. Okay, now again we are at this is one kind of operation. Let me finish all this. Okay, so delete. So delete means, let's say we j and s are both are not equal. So I'm saying that just delete this guy. Okay, so if I delete that, it will become a m and sm. Right, if I am deleting, means I'm not deleting from this string. Okay, I'm just moving ahead, means I will be moving my s1 pointer to the plus 1, means a next index. Now here I am not moving my j, means second s2 string wala pointer. Okay, now means it is replaced. So replace wala means, so I am just replacing whatever I have this here, I'm replacing with this whatever I need. Okay, so in that case I'm pretty much sure that if I replace them, I know that both these things will match. Okay, then I don't need to do any task. So I will simply say am and m. Done. Hope you have understood. Okay, if you haven't, please pause. Okay, please go back and watch the again. And here now, here comes the picture again. So yeah, so again 3 options: insert, delete and replace. Okay, so insert, so we are currently at j and we are currently at s. Now again I can see that yes, sorry, we are currently at j and we need to increment here. Okay, sorry. So we have made a progress in insert. Okay, so j and m are not equal. So again we have 3 options. So what is the first option? I can insert it. So if I insert that, it will become, again it will stay at j, then it will go to the point where I have nothing. Okay, so nothing. So whenever it has seen the size of the element, okay, whenever it has seen the size of the element, so I should return the set of characters which are available in the rest of the string. Okay, so here I have reached the size of 2, okay, which is my s2 size. So now I am currently standing here only. So to make these changes, okay, so I need to process the three characters. Now how much cost it will need to change all of those? Can I say 3? Yes, right. So what is that 3? Can I say that s1 dot size minus whatever the size here we took? So it is saying, now let's say here, let's assume that it is j. Whenever we have made j, then wherever we are currently, means we are currently at this particular j. So it requires s1 dot size minus I. Okay, if we have, if suppose we have reached s1 end, okay, s1 end, then it would be s2 size minus j. Okay, whatever the leftover characters in the s2, we need to process all of them. That's it. Okay, so here this is about insert. If we are making an delete, so we are just deleting that j, so we'll make a process to the next guy. So it is going to be a m, and again it's an we will be staying at the same, so we are staying at the m. Okay, we are staying at the m. Now then it's a replace, so I will replace this particular guy j with the one which I want. So it is going to be a m, and I will, if I replace that, I will move to the next thing, right? So if I move, there is nothing. Now how does it cost me? It will cost me around the size, okay, the size of this particular string minus where I am currently standing. So here I am currently standing at the first index, and the total size is 3. So 3 minus 1, it's a 2. Yes, right? To make this string completion, I need 2 more operations, either delete or insert or replace, whatever, right? So this is how you will process the particular tree. Okay, so this is going to be very big. Yeah, so that's why I'm not making. So I hope you have understood. So because we have watched like we have did a lot of problems. Okay, so if you haven't watched, please try it on your own and go and watch my previous videos where I have discussed plenty of problems. Okay, and let's see here. Cool. So let's see, right, let's try to write the code. Okay, where are we starting from? We are starting from the 0, means let's say we are having a 0 0 and s1 and s2. So this is what we are passing, and here we have a function which catches all these things. So let's say solve. Now what is the first character, like first case that we are going to handle? Let's say whenever my I becomes s1 dot a size. Okay, whenever my I becomes s1 dot size, then what do I need to return? I need to return whatever the set of characters I have in my s2. I need to return all of them, right? So let's say, so I need to return s2 dot size minus j. Okay, and if my j reaches the end, then I need to return s1 dot, like whatever the set of characters, okay, I have in my the current string, like remaining. Okay, now these all the cases that we need to handle. Okay, now what if, okay, what if 2, okay, let's say I have seen s and s, then I need to just move on to the next character, right? I don't need to do any operation. So because they are equal, okay, whenever they are equal, I don't need to do anything. Okay, so I don't even need to increase my count, right? So I can say that s1 dot I double equal to s2 dot j. So when this is the case, just return like just make a call, okay, call by improving, like by moving on to the next pointers. Okay, s1 s2, done. Now if this is not the case, then you need to traverse, like then you need to pursue the other 3 options. First one is insert. Okay, like what is the insert kind of thing? So it is, you are staying currently like you are not moving s1. Okay, you are not moving, so s1, you are only moving your j1, means the second string pointer. Okay, then s1 s2. Cool, this is the insert, and the next is delete, solve. Here you are not making the you are moving only in S1 string, because you are deleting that guy, right? You are deleting that, so you need to check the next guy with the that pointer which you are standing in the S2. So I plus 1 comma j S1 comma S2, and then next one is a replace. So what are you doing in replace? Okay, if you remember, we are just staying there itself, like we are moving on to the both pointers. We are moving both pointers. For delete, we are moving only first pointer. For insert, we are staying in the first pointer at the same position, but we are making progress in the second pointer. Okay, so for replace, solve I plus 1, j plus 1, s1, s2. Done. So out of all these points, like, so you for every operation you require 1 point, right? For every operation you require 1. So what you can do, so return 1 plus, so you need to consider the one which gives you the minimum cost. So minimum of insert, delete, replace. Yes, done. This will give you the output. Okay, this is just an recursive code, so still we need to convert this into the dynamic programming. So now let's simply go and try to convert our code. Yeah, so what is the thing that you need to require first? So you need two strings, so s1 comma s2. Then you need to take them up from the board. Yeah, then let's say int answer equal to solve I plus 1, 0 comma 0, s1 and s2. Then you need to print answer at the end. Okay, let's go and make a function called solve. So you will be accepting I, then j, then string s1, then string s2. So the base conditions would be like, if I is if I is reaching to the end, then you need to return the set of character, like you need to compute the set of characters which were left over in the second string, right? So s1 dot size minus the point where you are currently. Done. And if you have reached your second pointer to the end, then you need to return the strings which are left over in the first guy, right? Done. Now if not, if you haven't reached both ends, then you need to check whether I equal to j. Okay, so if this is the case, then return solve, just make a progress to the next set of characters. Okay, I plus 1, j plus 1, s1, s2. So if this is not the case, then you need to go with other options. Okay, what are all the other options? Insert, delete and replace. So when you are talking about insert, you are just moving your second pointer to the next. Okay, s1 and s2. And delete. Okay, let's say delete. Okay, so solve. So here you are making progress in the first string, but wherever you are in second string, you will be there only. Okay, and our last one is replace. So here you will be making progress to the both of the strings. Okay, then at the end return 1 plus minimum of all these operations. So it will give us the output. Okay, let's try to see. Okay, so let's say I have given a jump. So here it requires two operations. One is replace either J or M, either J or A with the S, and delete the other one. Okay, so it requires three operations at the minimum. Sorry, two operations at the minimum. Let's execute this. So solution building. It's taking some time because complexity is too much. Yeah, so we got the 2. Okay, so yes, it works. And if we wanted to convert the same to the dynamic programming, how can we do that? So very first thing that you need to do in dynamic programming is while you are converting your recursive solutions to the dynamic, then you need to first observe what are all the positions that you like, what are all the things that are keep on changing. So here I and j are keep on changing, so you will make a vector of 2D. The sizes of s1 dot size, then a vector s2 dot size, filling with the -1. Now wherever you are calling, just pass dp over there, and let me copy this. Then so yeah, here you are again calling. Then here now before checking with the character, just make sure you check in dp as well. So I j not equal to -1, just return dp of I and j. Okay, so before returning your answer, just store and return. Okay, I hope this makes sense. And let's try to change our inputs to be Sunday and Saturday. So we required 3 as our answer. So let's see. Yes, we got 3. And yeah, so it will work. Okay, so the time complexity of this particular approach is going to be m into n, and time space complexity is also m into m, and but it uses some extra space for the stack. So you guys know what to do to reduce that stack space. So if you want me to do that as well quickly, we can do that. Okay, so for that, let's remove this piece of code. But you require dp, right? Yeah. Int m equal to s1 dot size, and int n equal to s2 dot size. Okay, and instead of, yeah, so let's store this with zeros. And okay, so we require int I is equal to 0 less than m and I. So here let's replace it with m plus 1, and plus 1. Okay, so we require 2 for loops. Now let's see what is happening over here. So since it's a bottom up, okay, just tell me, okay, just tell me. So whenever you are standing at the your I is equal to 0, okay, now you require, so to compute the other strings, how much of time that you require. So do you require the cost of j, right? The number of operations that you required is cost of j. Yes. If, like I'm saying that if I is equal to 0, okay, just make your dp of ij equal to j. Okay? That is what we did over there. And else if, okay, else if j equal to 0, then how much cost you require? We require the cost of I. And else if s1 of I minus 1 equal to s2 of j minus 1. Okay. So if this is the case, what you need to do, so your dp of ij will become dp of I minus 1 and dp of I minus j, sorry, j minus 1. Yeah. So else, so if this is not the case, and for all other cases you need to store the one which is very minimum in the all the options that you have. Okay, what are all the, with the adding one. Okay, so dp of I minus 1 j, so this is one option that you have, and next one is going to be I and j minus 1, and another option is going to be I minus 1 and j minus 1. Yes. So this is it what we are doing in memoization as well. So at the end we will simply count dp of m and dp of n. Okay, and let's change our input to the something like a b c d e and c d e, okay, or c d j, okay, c d g. So here how many operations that we require? So we required these two, okay, so and we more required either you can replace e with the j, so that is one operation, and you can delete these through. So at max you required 3 operations, right? So let's remove this. Okay, so let's save this code. Okay, let's save this code and we'll run it. Yeah, it has some okay. We got the 3 as our input. This is what we expected, and this is how the code looks like, and you can easily compute the time complexity here. So if you see, we are using 2 for loops, okay, with the cost of n into m, and we are not making any stack space here since it's an iterative solution, and the time space complexity is going to be only m into m. Okay, so this is all about edit distance, and yeah.